Welcome to Vidyotma Physics. In this lecture, we are going to discuss formulas of electrical field, potential, along with their graphs for all the bodies that are in NEET and JEE syllabus. Very important part because often formula based questions are asked in both the exams. So without wasting time, let's begin. First, I will discuss sphere. Okay, sphere is divided into two category. One is solid non-conducting and another category is in which all behave similarly: solid conducting, hollow conducting and hollow non-conducting. So for solid non-conducting, I am interested to find electrical field at point P at a distance r. What is the formula? So two things you have to remember. One is case for outside and one is case for inside. So for inside, always remember that your electrical field varies linearly at as a distance. This is the specific formula you have to remember. KQR upon capital R cube. KQ anyway everywhere it will come. Small r, you have to remember that linearly it varies. So for graph also, if I want to draw the graph, so first there will be linear increment. Electric field is 0, 0 at center of the sphere, and then it increases linearly. What is this point? This is small r is equal to capital R. That is radius on the surface of sphere. Sir, what happens when we go outside the sphere? So it just behaves like a point charge, and you know the formula for point charge. This is the formula for point charge. And what kind of graph will come? Similar to rectangular hyperbola, not exactly rectangular hyperbola, but similar to it. So this is very easy, sir. So finally, we got the graph of solid sphere, electrical field. Okay, inside and outside. Inside, it depends on linearly, okay, on R, and outside, just like kind of rectangular hyperbola point charge. Sir, about potential. So for potential, I have one formula. What is that formula? You know that KQ upon 2R cube in bracket 3R square minus small r square. See, you have to learn this formula. It's easy formula. How I remember? 3 minus 1 is 2. So 2 is in denominator and 3 is in numerator. Are you getting it? KQ is common. I don't have to learn anything. So 3R square minus r square upon 2R cube. That you are going to use in gravitation chapter as well. Here what I want you to remember is that at the center, what is the potential? See, you tell me what was electrical field at center? Sir, it is 0. Okay. But what is potential at center? Potential at center, if you put r is equal to 0, then you will get, I will write here, V at r is equal to 0 or center is 3kq upon 2r. Remember this. Okay. Many times directly in the exam you get the question. Are you getting it? Electrical field is 0 at center, but potential is not 0. Yes, sir. Sir, what happens if we go outside the sphere? What is the formula for potential? So it just behaves like a point charge, and point charge, the formula is what? KQ by small r. Yes. Okay, then look for the graph. So this is the graph for potential till my radius comes or till I come on the surface. This graph will be parabolic. Now you don't have to exactly remember the graph, just remember the nature. So first it will be something like this and then it will decrease. So this is approximate graph. See, what is nature of this graph, sir? This is actually parabola. First half is parabola till small r is equal to capital R, that is parabola. Why parabola? Because here it is r square is there. Okay, this is y and this is x. So square is there, that's why parabola. And this is rectangular hyperbola. This is rectangular hyperbola. So are we very clear with the graphs and formula for solid non-conducting sphere? Fine. Now let us go to next part, and next part is, which three will come in next part? Conducting, solid conducting, hollow conducting, and next is what? Hollow non-conducting. Very good. So this is very easy. See, if inside I want to find electrical field, it is 0. No problem at all. Yes, sir, 0. And outside it just behaves like what? Point charge. So KQ by small r square. Very good. Excellent. So how the graph will look? So here there is no electric field, that's why 0. And when small r is equal to capital R, after that electric field, how it will vary? It will vary similar to rectangular hyperbola, not exactly but similar. Okay, this is the graph. No need to memorize it, just be with the flow, and you have to be logical. Okay, that's it. Sir, what about potential? Sir, electric field is 0 inside, that means is potential 0? No, no, that is not the case. Okay, if electric field is 0, then potential may be 0 or may not be 0. Fine. So here what is the potential then? It is constant and it is equal to kq by capital R. So beautiful. So my potential is constant, so this is the potential. Up till where, sir? So this is still small r is equal to capital R. What happened after that? Point charge, simple. Point charge. So our discussion for sphere is completed. We have covered both hollow and solid sphere, all type of conducting, non-conducting, everything we have covered. Okay, now let's move to the next part. And next body is ring. Very interesting. Often it is difficult to remember formula of ring, but be with me, we will remember together. Okay, anyway I don't know any formulas, I am writing it. Okay, so here first you try to understand what kind of diagram it is. So how the ring is like this. It's kind of ice cream cone kind of structure is there. Okay, ice cream cone kind of structure is there. So we are interested to find electric field at a distance of small r on the axis. So this r is from center. What, before applying formula, at least know what are the terms. Okay, first you tell me what is direction of electric field. Direction is pretty simple. See, this is kind of, imagine like this. Okay, imagine like this, it is an ice cream cone. So if you take any two diametrical opposite points, so how electrical field will look like? So here is the electric field outward due to this positive charge, and here is again outward. So if you can see that vertical component of these fields which are symmetrical, they will be cancelled. What remains is, sir, horizontal component. So always remember that electric field is what? Along the axis or ring. Okay, this can be MCQ directly asked in examination. Okay, sir, what else? So we are here to remember formula. What is the formula? So directly I will write, it is kq r upon capital R square plus small r square power 3 by 2. So simply remember that in denominator 3 by 2 power is there. Okay, for ring 2-3 times you write on the paper, then it will be very familiar with you. Okay, sir, what about potential? So potential is quite simple. See, if I want to find potential of the ring, simply what I have to do, I have to take this charge, let us say q1, kq1 upon this distance is there. For this charge also same distance. So can you see that distances are same? All distances are same, right? So total charge will be added. Yes or no? q1 plus q2 plus q3 plus q4 and whatever the distance is. So simple, my formula is kq upon r square plus small r square power 1 by 2. Are you getting it? Power 1 by 2 or root also you can write, same thing. Okay, let us come to the graph. Graph is very easy. Graph is very easy, don't worry. First you tell me, for potential, if I draw the graph, for potential, approximately graph we want. Okay, in exam we don't have to do PhD exactly. So in physics approximation works. So you tell me, if small r is equal to 0, what is the potential? So I will write, when r is equal to 0, at center potential is 0. No, it is not 0. How much it is? It is kq by r. Okay, and as this denominator increases, then potential reduces, right? That means at origin or at center potential is maximum and then potential reduces. So graph is approximately like this. Are you getting it? Okay, sir. How about electrical field? Now you tell me, what is electrical field? When r is equal to 0, what is electrical field? I think it is 0. Absolutely. Right? Okay, sir. And you have to remember this graph because they will ask in exam. Okay. See, one thing is here two factor are there, numerator r is there and denominator r square, and power 3 by 2 is there. So how graph will look like, you have to remember. So this is approximate nature of graph. Okay, it is symmetrical about x-axis. Remember one thing, that this electrical field is downside x-axis or negative I have shown. Okay, in negative y. Why negative y? Because here it is in which direction? Right direction. If you go that side, it will be in left direction. So direction changes here. One thing which you have to remember is at which point electrical field is maximum for ring. Directly MCQ can be asked in examination. So at small r is equal to r by root 2. Okay, and r is equal to minus r by root 2. That means at r by root 2 distance from the center, I will have my electric field maximum. And if you can remember, if your memory is good, you can also remember what is the maximum value. What is the maximum value, sir? It is kq, okay, here 2 divided by r square 3 root 3. Okay, this is what I remember, but you can check whether this is correct or not, but mostly it is correct. Okay, so let us go. So this is about ring. Have we missed something? Yes, some special cases there. Let me discuss. See, for special case, let me use different color marker. In the first case, when small r is greater than capital R. Sir, what you mean by this? That means my point where I am looking electric field is quite far. Okay, so if it is quite far, then what is my electric field? So see, if you go quite far na, this ring will appear like a point charge. So directly you have to remember that formula for electric field will become kq by r square, simply like a point charge. And second case is there. Second case, where to write second case? So second case I will write here. Okay, here. If small r is less than capital R, what that means? That means if this point P comes very near to ring, very near to the center, then what will be the formula? Now the formula will be for this kq divided by, here r will come and here r cube will come. This is not that I have learned it. Okay, simply if you apply little mathematics, if I take capital R square, say small r is less than capital R, so capital R square if you take common, so 2 will be cancelled and r cube will be there, capital R cube, and this capital R will be divided by this term can be neglected. Now if you have not understood what I have told, so here only understand how to remember the formula. Binomial approximation or simple approximation also you can get the formula. So this is about ring. Are you getting it? So for ring, all formulas you have to remember and graphs also. Let us go. Okay, so for ring, circular arc is also there. Circular arc, you know this circular arc? Yes. Sometimes they ask you in exam, right? In many MCQs which you have solved in coaching or anywhere, you can find this. Okay, okay, sir. First, what I need to understand is, what is the direction? Can you tell me what is the direction of electric field at center? We are only looking at center. So always remember one thing. See, it is logical. If you take two points, say this point is there, this point, electric field is like this. So sir, electric field is like this. So here again, horizontal components will be cancelled and vertical will be added. Are you getting what I'm trying to say? Here only vertical components will be added and horizontal will be cancelled. So effectively what happens is, my electrical field, how it is passing through center, okay, passing through center and away from the charge. So it is like a symmetric structure. Are you getting it? So if it was a negative charge, this arrow would have been upward. As you know that inside negative charge electric field goes and outside positive charge electric field travels. Okay, so sir, what is the formula? So this formula you have to remember. What is the formula for this? So 2k lambda by r sine theta by 2. This is important formula. I will suggest that you remember this formula as it is, because many times they ask you question. Okay, and if formulas are not there, then how we are going to solve? Sir, what is lambda here? Lambda is simply what? Charge per unit. Charge per unit what? Length. So what is charge? Let us say q charge is there. Q charge on this r, q charge is distributed. So I will simply write q divided by, sir, what is length? Length is r theta. If this is radius r, length is what? R theta. Yes, very good. Let us take sample example. Now these are two examples. So let us say if lambda is given to you, okay, linear charge density is given to you. First you tell me what will be the direction of electric field at the center due to this arc. Negatively charged it is, okay. First what you remember, so electric field will pass through center, it is symmetric, okay. So electric field has to go like this, but now here it is negative charge. Negative charge means it will be towards negative charge, so electric field will look like this. Are you getting it, sir? And what will be the magnitude of electric field? We will use this formula. So simply I will write electric field here is 2k lambda by r, whatever radius is, and sine. What is angle? Angle is theta. Theta by 2 here, so pi by 4 and divided by 2. So how much it is? Sine pi by 8. Are you getting it? So how much answer I will get? 2k lambda by r sine pi by 8. Again, you don't have to remember that value of pi by 8, but you will find such in options, okay. So maybe instead of pi by 4 it may be pi by 2, or any angle can be there. I just have written. So here you tell me, in this semicircular arc, can you tell me what is the direction of electric field? Can you tell me the direction? Can you tell me the direction? Pause the video and try yourself. I will tell now. Look here. First, what I am seeing is, see, two arcs are there. One is positively charged, one is negatively charged. So have a look only for positively charged, okay. So positively charged, where it will be, towards positive or away from the positive? Sir, away from the positive, okay. Okay, so away from the positive, it will be like this, electric field. Agreed? Yes, sir. Now for negative charge, you tell me, negative charge, it will be toward and again passing through center, okay. So it has to be symmetric about this curve. So my electric field is like this. So I want net electric field. Now can you visualize that? Let us say this is my E positive and this is my E negative. That is, electric field is not negative, it is just due to negative and positive charges, okay. So what is my resultant? So two vectors are there and almost everything is symmetric, so they are equal vectors, right? So if we take resultant of these two vectors, it will bisect and it will be along this. So this is my net electric field, which is in which direction? In positive x. Are you getting what I'm trying to say? Yes, sir. So simple it is. Anyway, if you have to determine magnitude also, so any one electric field you can determine. How you can determine? Okay, by the way, what will be the E net? E net will be, so what is the angle between them? So this is 90 degree. Can you see that this is 90 degree? Yes or no? Because see, this is entire 90 degree. So this angle, anyway it is 90 degree. So that means this is 45 and this is 45. So this is 45, again this is 45. 45, 45, 90, and again this is 90. Are you getting it? So here, what E net I will write? Vector, simple. So 2a cos theta by 2, resultant of two vectors, equal vectors. So 2e cos 90 by 2, that is cos 45. And sir, how to get value of E? It is again very simple. So E is what? In this case, what is E? E is simply 2k lambda by r. And here it is, what is the angle? Angle is 90 degree. This angle you have to take, entire angle, arc, which makes, how much it is? 90 degree. So sine 90 divided by 2. Here it will be. Okay. So that calculation part you can do, just I have discussed the basic formulas. Sir, what is the formula for potential? This is about electric field, okay, about circular arc. Potential is also very easy. See, here if plus q charge is distributed, okay. If I want to take only this charge, what is potential due to this? You will say, sir, k dq upon r. Let us say this is radius, k dq upon r. Here also k dq upon r, k dq upon r. If I add everything, simply what I will get? I will get k q upon r. Are you getting it? Yes, sir. Very easy. Okay. Suppose what I can say is, let us say they have not given small q. What they have given is, they have given capital Q. What is capital Q? They have given you that this entire charge plus Q is distributed, okay, and this small q is not given. Can you tell me then formula for potential in terms of capital Q? Yes, it is very simple. What you have to do? small q is not given, plus q is given. Okay, capital Q is given on entire ring, and only on this part they are asking potential. So what I will write, K upon capital R. What is relation between small q and capital Q? Can you tell me the relation? What is relation between small q and capital Q? See, I'm writing one thing by unitary method. Small q is equal to capital Q theta upon 2 pi. Are you getting this relation or no? Yes or no? Tell me. Yes sir, we are getting, or no sir, we are not getting. See, one thing. For entire circle, how much is the charge? Capital Q. For entire circle, entire ring. So for a small theta part, how much will be the charge? Theta upon 2 pi. Unitary method. Come on. Okay. Okay, sir. So simply I will write Q theta upon 2 pi. Are you getting it? So this is the formula. Two formulas, don't have to remember anything. Just logic I am saying. KQ by R you understood. When single charge directly it is given. If it is not given, then what you will write in terms of capital Q, that is entire ring charge they will give sometime. So suppose in this case I want answer in terms of capital Q, capital Q. So what I will do, so I know potential formula, what it is simply sir K Q by R, but I don't want in terms of small q, I want in terms of capital Q. Let us say this charge is not given, so what I will do, K upon R. How to find capital Q? Sir, it is very simple. How? So I will write capital Q into theta. Theta is how much? Pi by 4 upon 2 pi. Okay, so here pi and pi is cancelled, so what it will be? KQ by 8R. My answer will be KQ by 8R. Is it easy? Yes sir, very easy sir, very easy. Okay, can you tell me what is potential here? Can you tell me what is potential at O? Sir, it is 0. Yes, absolutely it is 0. See, this plus charge potential and this minus charge potential will be cancelled. See, potential is not a vector quantity, it is simply scalar, you can add directly. Similarly, these two charges symmetric, everything, see the distance, this distance and this distance is same, so this will cancel each other, and what is potential at center is equal to 0. So this is about complete concept of, see what we have discussed, ring, electric field, potential, then circular arc, electric field, potential. Now let us move to the next part, that is disk. Sir, disk, now see, from this part not too many questions will come in your exam, but I will discuss. Okay, I will discuss, because if question comes, then what to do. So what is the formula? Anyway, this formula, how you will remember this? See, sigma upon 2 epsilon naught 1 minus cos theta. Let me discuss. First, disk, where we are looking field on its axis, okay, and this angle is theta, the same angle. Ring and disk is more or less same, just you can consider disk as made up of multiple rings. Okay, multiple rings. Okay sir, so this formula sigma upon 2 epsilon naught, you remember for a disk it is sigma upon for a thin sheet, non-conducting sheet, it is sigma upon 2 epsilon naught. Yes sir, absolutely. So 1 minus cos theta extra you have to remember. Okay, yes sir. What about potential? Potential also same formula is there, sigma upon 2 epsilon naught 1 minus cos theta, and in extra what comes is this under root of r square plus small r square. Now this formula they will never ask, I will suggest not to remember, but what you should remember is this. And one special case you remember. What is that special case? That when I go very near to the disk, means what sir? Small r is less than capital R. That means my distance from the disk is very small. So this is a disk, suppose this is a disk, okay, so I am at this point right now, so I will go very near to this, very near to this. Okay, so when I will do, can you imagine that as we go near, what happens to the theta? See, right now theta is like this, right? So as we go near, can you see that theta is increasing? Absolutely sir. So what happens is, when you go very near to disk, that at that time theta tends to 90 degree. And when theta tends to 90 degree, if I write electric field, what it will be? Sigma upon 2 epsilon naught 1 minus cos 90. And what is the value of cos 90 sir? It is 0, right? So E is equal to sigma upon 2 epsilon naught. That means you have to remember that disk behaves like what? Thin. non-conducting sheet. Are you getting it? This is the same formula which we will now discuss. So disk behaves like a non-conducting sheet. When, sir? When we are very near to the disk. Because if you are very near, for that person, for that point very near, the disk will seem like a infinite sheet. Are you getting it? So same logic applies. Charged wire. Okay, charged wire. Another thing is there, like another concept here. Charged wire, again 3 categories you have to remember. Formula for charged wire, then hollow cylinder and metallic solid cylinder. Hollow, which hollow cylinder I am talking about? Both conducting, non-conducting is fine. And solid cylinder. Metallic solid cylinder, same formula will be there. Sir, so what is the formula? And by the way, it is infinite, okay? This is infinitely long. Infinitely long. Okay, sir. So formula is lambda upon 2 pi epsilon naught r. Okay. So here, sir, what is this lambda? Lambda is nothing but linear charge density. Okay. Charge per unit length, that is. Graph is important here. Graph is important because sometimes they ask in MCQ. So can you see that it is a rectangular hyperbola? Absolutely. So graph is like this. Done. So only one formula and one graph for what you are going to use? Hollow cylinder, metallic solid cylinder and charged wire. Sir, what about if cylinder is not hollow, it is a solid and non-conducting? Solid and non-conducting. See, for solid and non-conducting, these are the formulas. Okay. And rho is what? Rho is simply volume charge density, because in non-conducting, where charge reside? Inside the volume. Okay. Very good. Now here what you have to remember is that inside cylinder, inside, you remember solid sphere? Inside solid sphere, how was my electric field behaving? Linear, first I have explained, right? And outside solid sphere, not, I'm talking about non-conducting. Sir, like rectangular hyperbola. Here also same thing. See, inside, if I go inside, linear is there. So the graph will be linear. And if you go outside, it is rectangular hyperbola. So here it is rectangular hyperbola. Are the graphs same or similar? They are similar, they are not same. See, first part is okay. Nature of graph for first part is straight line. But this is exact rectangular hyperbola because it is small r is there in denominator, but there it was small r square. So that is not exact rectangular hyperbola, okay? Very good. So this is about solid. And last part, infinite sheet. Now from here, we are confused. So always remember that conducting sheet has a greater, what we will see, electrical field. And how it is given, sir? Sigma upon, sigma is surface charge density, okay? Sigma upon epsilon naught. And for non-conducting, how it is? Sigma upon 2 epsilon naught. One logic many students ask, sir, why for conducting the electric field, if surface charge density is same, why conducting electric field is more? Actually, in case of conducting, where the charge resides, charge reside on the surface, right? So when charge reside on the surface, it contributes more to the electric field. But in what happens is, in non-conducting, charge also resides in volume. So that reduces surface charge density, or what we can say, that increases area. So in basic, what you will remember logic as, since charge reside on the surface for conducting materials, so electric field is more, and inside volume, that's why electric field here is less. So here it is sigma by epsilon naught, and here sigma by 2 epsilon naught. Another important thing, what important thing, sir? Here you have to remember that the electric field does not depend on R. So E does not depend on R. That means practically wherever I go, my electric field is constant. So for a disk also, that condition will be there. When we go very near to the disk, same condition will be there. Can you tell me the graph? If it does not depend on R, that means electric field has to be constant for both. So graph will be like this. Are you getting it? So we have discussed, once again, let us have quick revision, whatever we have discussed. Solid non-conducting, what is potential, what is electric field, inside outside graph in detail, sir. Also about, how about conducting, hollow, everything. So what you have to do is, what is your task? See this lecture 1 or 2 times, and after that what you do is, you take a copy, make such diagrams, okay? One on single page, make a diagram, and in front of that, with small inside a small box, write graph and formulas. Write 3-4 times and you will never forget. Okay, all the best.